Good morning. End of what week, whatever, right? But it'll be the end of the content for exam 3. So I don't quite want to call this new content because it's not really all that new, and we'll see it's very similar to what we did Tuesday with 13.4 with that integration. We're going to use that. There's really just one step, and I'll in the presentation you'll see I'm going to phrase what we were doing similarly. However, there is one thing that you will want to do, and that's we're going to start off with graphing everything because we've got to see things, and that'll become clear. Hopefully become clear. I do have, so we've got this content for test 3 that takes us through. There are 2 parts, learning resources for chapter 13. I think it's a review, some videos, some previous videos to the content. So it might be helpful each time I do it a little bit differently, so you could look through those. But I've also got, let's see, I think I was looking through here. So I have them by section. I don't think I have 14.2 in here for some reason, but some of these sections are go over more and more problems. So again, take a look at what's in here. I will also over the weekend. This is what I had in here from spring. There has been a little revision. So there's an in-class review. You could pretty much use this one. What I do is I highlight certain questions and I say do at least these. So maybe it helps you work the review almost as if it were a test. So I highlight, I'll be honest, I look at the test and I say, okay, you've got to be able to do a problem like this. I'll highlight them and I try to make them match about what's on the test. So you could, if you just do the highlighted ones, it's close to taking the test. So do that. It's not that you want to ignore the other ones, but definitely if you're on limited time, do at least the highlighted ones, and maybe come back to them, because sometimes when you do a review, you get through it, but you're using your notes or you're looking at things, you're learning it, you're relearning it or remembering it. Set it aside, and maybe the next day, or maybe do it in the morning and then the afternoon. Give it some space, and then look at it with fresh eyes, and take it like a test, and see how much of it you remember. So that's because I get some students asking, how can I do better on the test? I study and I do all this, and the thing is tests taking is different than studying because you don't have access to all your resources. You're not in your safe space either, right? You're in this room with all the stress and oh man, I got to do this. But when you're in your safe space, sometimes you're more relaxed, whatever. So, but do that of working through the problems as much as you can without notes, just like in a test setting, and then go from one to the other. Do that at least once, and again, the more if you can do it, it'll help you deal with sort of the anxiety part of the test taking as well. And while sometimes they rephrase the test questions slightly differently, that I know it can throw you off a bit, at least you will have worked through problems and work them as if you were going to hand them in as your work for a test. So do all of that. So make it as real as you can make it. And so that's one of the things is this version has some of them highlighted. In fact, I'll just click on it and we'll kind of do that. And we'll come back and sort of focus on those or not. And I'll see if I have any videos. I thought I usually have videos for these. Sometimes at the end of the semester I'm so busy I don't get them done. But they do have 4.2 here, so area between the curve. Again, notice while there's more questions that you can work there, those are always good. But those highlighted ones are just to kind of help you focus and say, okay, just do those, and that's about the size of what a test would be. Okay, so that's just kind of, since once we're done with what we're doing today, you've got that homework, but then you've got time to start reviewing over the weekend so that Tuesday, when we do our in-class review, we can work some examples, we can see what questions you still have, and maybe talk more about strategies. Okay, so we're going to do 14.2, and I apologize, I realized it was saying 14.1, and I went into WebAssign and said, there is no 14. What happened to 14.1? Oh, it's 14.2, because even on the power, let me, where do we want to do? Okay, oh. So area between two curves. Get my pencils. Yeah, we'll leave it blue. Okay, so where I'm going to start is I'm going to start with the partial slide from Tuesday. So we talked about this function was cost of baseball caps, and this was a marginal cost, so we were integrating it. So if you go back to that particular lecture, we worked all the way through it. And the second method we did was this graphical method, where we got the area under the curve simply by graphing the derivative function, getting the curve, inputting the endpoints, the boundaries from 1 to 200, or 100 to 200, sorry. And that area under the curve was the same, that area was the same as if we integrated and used the fundamental theorem of calculus. What I want to highlight here is that what we're doing today is really exactly the same thing if we rephrase this one as not being between 0 and the x-axis, but not being between the function and the x-axis, which it is. If we rephrase that the x-axis is actually a function itself, it is the function y equals x, or if you want g of, no it's not. I think I need a little bit of a break. Yesterday, if you watch that was a mess. They kept me on track though. I kept making mistakes, but hopefully the mistakes were helpful to get it through. So this y equals 0, so it's like g of x equals 0. That's actually a function, right? It's a constant function. It's that horizontal line. So what we're going to do is we're going to rephrase this as the integral from 100 to 200, 4 minus 0.001x minus 0, minus the other function. Okay, so you can see why we didn't need to do that. If you subtract 0, nothing happens, right? It's really the same thing. So what we're doing today is instead of having y equals 0, we actually have a function there. So we didn't do it directly, but what we'll do is we'll subtract that second function, combine like terms, if there are any, whatever, we get a new function, and then it's just the same thing we were doing on Tuesday. Okay, so this will kind of be some new practice, just one extra step sort of. But to do that, remember, to get a number, we have to do the higher function minus the lower function, right? The bigger number minus the smaller number to get a positive value. And as we're going to see in the homework, sometimes functions do weird things, right? They go up and they come down, and sometimes one function starts on top and then the other one changes. We're going to look at an example with that in there. So this is very graphically oriented. You're going to need to look at the graph to see what's going on, which function's on top for which part, and then if it changes. But we're going to be okay, again, because we can also use the technology to do it, to come up, to check our answers and everything. So let's sort of press forward into this area between two curves. So notice with what they're giving us here, they show us a graph, which again, that's pretty much what we're going to do. They don't tell us what the functions are, but from the graph we can see f of x is the higher function, the red one, it's on top, and g of x is the lower function, it's on the bottom. And so, instead of going down all the way to the x-axis, what this is going to do when we subtract the two, it will give us the area between those two functions. Okay, so the way we do it is we just, graph it, figure what's on top, what's on the bottom. We subtract the two functions, and again, we'll combine them with subtraction, and we'll have it where there's really only one function. We will be given these endpoints most of the time. Occasionally, and I did see it yesterday, when I looked at the homework real quick, I didn't graph them. I just looked at the boundary. It will give us most of the boundaries, but occasionally we're going to have to find intersection points, because sometimes they'll say from A to the intersection point, or from A to the closed part, so we can see that this intersection point is. So that's the other thing we need to be able to do, is once we graph it, be able to find intersections. And I will show you the TI-84 has that tool in there. If you've got a Casio, it also has that feature in there, but it works differently. I do have one, and I practice it a bit, but I forget it. So if you've got a Casio and need to look at that, we can do that. Okay. And I could even, I've got sort of one of these dock cameras at home, so I do have a Casio calculator. If you've got one and need to see some of these, send me an email. I can make a few quick videos that does the same thing. Okay, so let's go in directly to today's with an example. And what I was messing up, I was missing negative signs here and there, and I was putting in. As you can see, they're very similar functions. We've got f of x, which is negative x squared minus 3x plus 4. G of x, which is a very similar function, but it's a positive x squared minus 3x minus 4. So they're very close, and when I was doing this, I kept messing up with the negatives, and then when I solved it, I messed up with the negatives a couple times. So try to keep me on track. I'll see, it's early morning, is usually I'm fresher, so hopefully we get it right. So we're going to take these two functions between -1 and 1. So the way we do this is I'll put it up here. We're going to integrate from -1 to 1. We need to figure out which one's on top first. Okay, so I'm thinking f of x is, because it's negative x squared, and I know that would be like an upside down u, so it would be nice if it is. But let's graph it. And I even graphed it wrong because I messed up on the thing. So let's see. Hopefully, oops, I don't want that. I want to get out of the presentation. We'll keep these things. Maybe make it a little smaller. And I want to get into my graphing calculator, which hopefully will just open up for us. And again, you could use decimals. It's nice here if you have a color version of a graphing calculator, because then you can do a red and a blue curve, and it's easier to see. If you have one of the black and white versions, it'll work. You'll just have to be paying attention while it graphs to see which one comes first. So we'll be doing this a little bit later. So I'm going to clear these out. And a little bit later, I'll tell you about this y1 minus y2. In fact, I'm going to delete it for now. But that's something you can leave in there. We'll show you how that works. So I'm going to be a little more careful this time, like I tell you to be, right? So I should listen to my own advice. We go negative x squared minus 3x plus 4. Okay, so that's in there correctly. Enter, and then I'm going to put the next one in, which it's always is positive x squared what is it? It's at minus 3x, yeah, minus 3x minus 4. Minus 3x. And the thing is when this graphs, the the system showed, the slide showed the graph, and the graph wasn't matching up. I don't know why I didn't catch it, but I just didn't. You know, sometimes we just push forward. Anyway, I'm going to do a zoom standard, which puts it sort of at the factory window. Sometimes that's a good fitting window, and for this one it is. And I can see and again, this went so fast, but the blue graph is on top, the red graph is on the bottom. And I go back, the blue one is this, so f of x is the top graph, right? G of x is the bottom graph. I think there's actually, maybe it's format. If I go second format, I think let's see what happens if we turn the labels on. I think that means it will label the graphs. Because again, no, that just gives us x and y. Anyway, I need to play with it a little bit more than I do. I think there's a way to put which graph is which that will show you, but what we know is f of x and then g of x. So the first one is on top. And so this tells us we want to do f of x minus g of x dx. Okay. And so what we end up doing is we integrate from -1 to 1. I'm going to put f of x in here, negative x squared minus 3x plus 4. We're going to subtract g of x, but it's not just put a subtract and copy the g of x. Make sure you put a parentheses, or that subtraction sign needs to distribute to each of those terms. And that's where I was messing up. So that's why I'm going to try to be real careful. Use whatever method works best for you. I've seen some students, oh, this is negative, so all these signs will change. That's a good approach, because that does work. I'm just going to do this so it's sort of recorded. So I got all the right values there, not dy, dx. Okay, so now the first step we got a little algebra to do. We need to combine like terms. We need to combine these two functions. And so what I kind of do is, okay, this negative needs to distribute, and distribute. So this becomes negative, this becomes positive, this becomes positive. Okay, so I've taken care of that negative. So then I have a negative x squared here, and I need to combine it with a negative x squared there. So going from -1 to 1, I get a negative 2x squared, right? -1 and -1 combine to be -2. Negative 2x squared. I have a negative 3x and a positive 3x. Combining those, 0, right? So that part disappears. And I'll even come up here and say, okay, these guys cancel each other out. I have a positive 4 and a positive 4. So that's going to give me a +8. And now notice we are at the place we were at on Tuesday. We just have a single function going from boundary. We just integrate it. Integrate it, not disintegrate. Okay, we integrate it. So let's go ahead and do that using the FTC, Fundamental Theorem of Calculus. Big words for integrate it and then plug in the boundaries, right? So next step, integrate this. So 2x squared, or negative 2x squared, is going to become negative 2x to the third divided by 3, right? Add 1 to the exponent and divide by that new exponent. That's integration. 8, when we integrate that, remember that's sort of like 8x to the 0. So when you add 1 to 0, you get x to the first power. This is 8x. We don't do the plus c. Instead, we say, here's our limits, our boundaries. We're going to go from -1 to 1. And what that tells us to do is the first step is to plug in positive 1. So we get negative 2x, not x, we're going to plug in 1. So everywhere there's an x, we plug in a 1. Come on. Square it. Why do I have dx? Didn't I say 2x? But I wrote dx. Negative 2 x squared. Okay, we're on track. I was on cholesterol medicine, and I read it can mess with your memory and stuff. So I stopped taking that about 2 months ago, but I feel like it's back. Yeah, blame the cholesterol medicine. But thank you. See, you just got to pay attention because I'm not. Yeah, don't let me drive. Okay, there we go. Okay, so slow down, little crow. So then it's plus 8 times 1. So that's the first function with 1 plugged in. Okay, we okay? Good. And again, check me on this. And then we're going to subtract the second part, which is this function with negative 1 plugged in. And again, this is sort of where I was messing up. So we get negative 2. Okay, that's good. We get a negative 1 to the third, not squared, divided by 3. And then we get plus 8 times negative 1. And then there's another parentheses here. Okay, so this, again, we've got it down to where it's all arithmetic, right? We just plugged, we've got our function, we integrated, got our function, plug in the top value, plug in the bottom value, so get those two values, get those two numbers, and then subtract them. 1 to the third is still 1, so this is negative 2/3. Bring this down, negative 2/3. 8 times 1 is 1, so that's a plus 8. And I'm going to calculate that, so that's 8 minus 2/3. Now, when you're doing WebAssign, oftentimes they won't accept decimal answers. They don't say it, but so they want it as a fraction. Or there's one that you've got like natural logs that you put in, you've actually got to use natural log. Or if it's like e to the third, you've got to put in e to the third. You can't do the decimal equivalent. So this is 8 minus 2/3. So 8, think of it as 8 over 1. We're going to get a common denominator of 3. 3 times 8 is 24. This is negative 2 over 3 plus 24 over 3. That's going to give you 22/3 for this first part. Then we've still got the subtraction to deal with, so I'm going to subtract. Let's go ahead and calculate all of this. We've got a negative 2, negative 1 to the third, right? There's 3 negatives. It's still negative. So you got negative 2 times negative 1. It's going to be positive 2. Positive 2/3. Here we have a plus 8 times negative 1. This is going to become negative 8. So inside here we've got 2/3 minus 24/3. Again, turning 8 into a common denominator of 3. So we're going to get negative 22/3. Negative 22/3, right? So we get negative 22/3 in here. We're going to subtract it. A negative and a negative make a positive. So we're adding 22/3 plus 22/3. This should be 44/3. I'm also going to put that in my calculator because I'm going to show you how to use the calculator to do it with, well, how to do it with the calculator. But the calculator is going to give us a decimal answer, so I want to see if this analytic answer matches what the calculator gives me. This is also 14.6667. So it's 14 2/3, basically, right? And for this one, the answer we would enter into WebAssign is the one with the fraction rather than the 14.666, because it'll mark it wrong. And I had students afterwards coming and say, why is it, I did everything you told me. And I says, yeah, and you got the right answer, but WebAssign wants it as a fraction. And it doesn't say as a fraction. Sometimes, I think if you click on it or you hover over it, it'll tell you that, but other than that, it doesn't. Okay, so now let me show you the second method. Remember the last time, yes? On the test, if it's a multiple choice, then you just have to choose the right one, so you have to know. If it's open answer, I will take it either way. I will take it either way. So yeah, on the test you want to say decimal is going to be easier for me to work with. Go ahead. Okay, yeah. A right answer is a right answer. In fact, actually, I kind of prefer the decimal because I know what 14.66 is. I know it's almost 15. 44 thirds, I'm not really, I don't have a gut feeling for what that means. Yeah, I know it's a big number. I know it's not, it's not 1/3. It's bigger than 1 is about all I can think of. But I have to do a calculation, and this does it. So let's see. Let me get back to my graphing calculator. Since we have it graphed already, we're going to go from -1 to 1, so it won't include everything. But the way we can do this is we do the same thing. So I'm going to show you sort of a shortcut to do this, but it involves a few button presses, and you might not remember. What we could do is retype f of x function, and then subtract parentheses the g of x function. We could retype it all. That's an easy way to do it. Or, well, not. It's easy to do, but it's time consuming. Or if you remember, there's a special key called vars. Vars for variables. And I always, you'll forget it. At least I forget what vars is, because so I think of a pirate. How would a pirate say it? Vars, maybe, so kind of get that in your mind. Vars is what we want to do, which is variables. And we want the y vars. And there's the function. And so once you do this a few times, you see there's y1, y2. What it's going to do is whatever I got in y1, it's going to pull that function. So it's sort of stored there, right? And so I think I'm in y3. If I hit enter, let me see. Yeah. So now I've got y3 is going to be y1 minus, and what we want it to subtract y2. The cool part is if you set this up now, you can basically turn it on and off, so you don't ever have to remember how to set this up. Go to yvars, enter to get into functions, and now we want y2. So this is going to take y1, subtract y2. That's exactly what we want to do, but we don't have to retype it in, because every time I retype, I have the possibility of doing a copy error, right? So this one, here's my two functions. The thing is this is going to make for a very messy graph. So you come over here to the equal sign. We're going to turn off the top two. Don't delete them, because if you delete them, then there's nothing in y1 and y2, and then the third one is basically empty. But if you hit enter, that turns it off from the graph. It's still there. It's still stored in y1, and it's still stored in y2, but it's not going to show up on the graph. We're just going to see the combined graph. Okay? And there's the combined graph, and what we're going to do is we're going to integrate it from -1 to 1. Second, calc, integrate, number 7, and it asks for the lower limit. The lower limit is -1. The upper limit is +1, and it shows us that area is 14.666, which is what we got. That's 44 thirds. So now we've got some, and that's where I was looking for the big thing, and I had the wrong number there. It didn't match what I came up with, but that helped me find my errors. So if you want to see someone making some mistakes and figuring out why they got it wrong or how they did it, watch yesterday's video lecture. I did it a couple of different times with help from students, but I didn't get the right answer. But this time we got the right answer, and so it matches what we got by doing the fundamental theorem of calculus. So we're feeling good, right? We're feeling confident. When I got the wrong answer, I didn't feel confident, but at least it told me that I needed to check my work, and lo and behold, I had a negative error. And so I ended up subtracting when I should have been adding, or adding when I should have been subtracting. So, but it's all good. We could catch it. Yes?
Can you go over what you did after having y1 minus y2?
Sure.
One more time,
So after y1, y2, with the TI calculator at least, you can turn the graphing parts on and off by the equal sign. So notice this equal sign has a highlighting around it. That means it will be graphed. Over here, these were highlighted, so it would have graphed. I'll show you what, if I didn't do this part, when I go to the graph, I see the original and I see the new graph, and it just, there's too much going on, especially if you don't have a color calculator. So that's why you just want to turn them off. You don't want to delete them, but you don't want to see them. So you can turn graphs on and off by doing that. And eventually, when you move on to the next one, you may want to turn y1 and y2 off, and just have, or sorry, you may want to turn y3 off, and do it and then turn it on and off. And what you might also want to have in here is, I'll show you this because it's just sort of a reminder. Again, that's also why it's recorded, so you can go back, because again, by this afternoon you'll probably forget about what vars does. How did he get there? The vars button, notice it's bright red here, over to y vars, hit enter. This time I'm going to subtract them the other way, y2 minus y1, because that's if y2 was on top, right? It might happen that way. So then I know which one to turn on, which one to turn off. And again, I go to vars again, y vars, function, y1. So now I've got the subtraction going the other way. What do you think is going to happen when I subtract in the other direction? I'm going to get negative area. So notice this will be the pink one. I'll leave both of these. So there's the one I want. Here's, if I did the other one, I would have got negative area. So the thing is if you get them wrong from which one's on top and which one's on the bottom, you get the same, you get the right, still will get the right answer numerically, but it'll be negative instead of positive. And so you could just say, oh, I'll just be lazy and just choose one. If it's wrong, I get a negative answer, but I know just to make it positive. Okay, but do look at the graph. And again, you can come here. Okay, we don't, for this one, we don't want this one, so we turn it off. But you can leave those there, because maybe during testing and stuff, it evaporates, you don't remember. That's something on testing I would show you. Oh, it's the vars key. I can't show you all the steps, but I can remind you of which key to push on something like that. But better if you can either remember or just leave them there, right? And I turn them on and off. Be able to turn them on and off. Good, so far so good? Okay, so let's just look at a couple more examples, and then we'll call it good for this section. Okay. So now it actually, this is the textbook. So I took their PowerPoints, and they kind of walk us through it. It says, basically this is just going to do what we did, but it might be helpful to review it this way, well written out and everything. So we're going from A to B, f of x. So this is the general, and since this problem tells us go from -1 to 1, they write that up. So we did that. They've got their functions labeled. They looked at the graph so they can see which is on top, which is on the bottom. F of x is on top. So then they put in the two functions, and they put those parentheses so that you know that that subtraction is going to distribute to g of x. So signs are going to change. Otherwise, you don't get the right thing. It's simplified to this. What they did, though, is a nice technique. I had it as -2x squared plus 8, and a lot of times if you put the positive term first, you'll have less problems with the negatives. Leading negatives is where I have problems a lot. So I should have done what they did, and I wouldn't have had all those problems yesterday. So, and you can do that, but at the same time, it does look different. Some people say, how did they get that? Well, they switched the order because it's addition is commutative. Okay, and then they go ahead and integrate it. And notice the negative is in between, so it's probably less problematic this way than the way I did it. But, you know, we do what we do. So just kind of get in tune with what you do, what works. They didn't show all the steps, but yeah, they plugged in the positive one, and then they subtracted plugging in the negative one, and they end up with 44 thirds. Same thing we got, or if you turn it to a decimal, 14.666. Repeating forever. We good with that? Makes sense? Okay. Now, on the exam, there is a question similar, and I'm going to walk you through the steps. It'll be different than this, but I thought it was important enough to, in advance, get you to think of what you're going to need to do also for the exam, because I didn't see in the homework, I did now, there's one where you have to find the intersections, but this time we're given the same function, so we don't have too much different to do, but we've got the same function f of x, same function g of x. So this is going to be walking you through what you need to do. But they don't give us the endpoints, they want the area between the points of intersection. Okay? Area. So now you're going to need to know, you're going to have a graphing tool, graphing calculator that can get you those intersections, and those become your boundary. So they're not saying going from -1 to 1. We got to figure out where they intersect. Okay? They want us to do it algebraically. So we will do that, and we will do it with the graphing calculator. When are two functions equal? Oh, sorry, I said that backwards. When do two functions intersect? When they're equal. Okay, I gave the answer. Too much jeopardy, right? I gave you the answer before I asked the question. So when two functions intersect, that means that they're equal. Where they're equal, they intersect. Okay, so we're going to put f of x equals g of x. And again, actually, I might do this with the graphing first, and so I know where those intersections are, and then I'll come back and do it algebraically, so I know what I'm looking for. Again, we could do it in either order, but let's just, since we've got our graph here, right, I'm going to turn this one off. I'm going to turn the original 2 on. And I think yesterday I put a plus 3x here, so even my graphs were wrong. I'm going to graph it. There they are. I need to find where these two intersections are. We're going to do it algebraically, yes, but we can also do it with the calculator. So here we have a feature. If we go second calc, notice the calc is above the trace key, and we've got a feature that will give us the intersection. So we do number 5, hit enter. It's going to ask us 3 questions. The first question is, which is the first curve? And it's sitting on a curve. We can just hit enter. Yeah, that could be the first curve. Asks us, it jumped to the other one and says, is that the second curve? And we could just say yes, because it doesn't know that there's only 2 graphs on there, but it's kind of anticipating that's the intersections we want. And then it's going to ask us for a guess, and this is what's going to happen. When we hit enter, it will find the closest intersection. So notice we have 2 intersections, so for one of these we're going to have to be careful and get closer to the other one. For right now, I can just hit enter, and it will find the closest intersection, which happens to be the one to the right. It's intersecting at x equals 2. Y equals -6 as well. So we'll use that when we graph it, but x equals 2. So that's going to be positive 2, right? I need to find this other one. It looks like it might be -2, but let's find out for sure. Second calc, I have to go ask for the tool again. Give me the intersection. First curve, I say yes. Second curve, I say yes by enter. But for my guess, if I just hit enter again, it's going to find that same intersection. I just need to walk it over and say, hey, give me this other one over here. And I don't have to get on it. I just have to get close to it. And now the system will find that intersection, and it shows it to me here. negative 2. So x equals negative 2, x equals positive. Those are my two intersections. We okay with that? Okay, so again, if you haven't used this part of the calculator before, a little bit of practice, it's good to know this feature. Let's see what I go back here. So I'm just going to put that down as a note, x equals negative 2 comma 2. So that's going to be my boundaries. But let's do it algebraically. We get negative x squared minus 3x plus 4, that's f of x, equals x squared minus 3x minus 4, that's g of x. And we now need to solve for x. I see an x squared here, so maybe I add x squared to both sides. I'll do it maybe a little slower this time, so then we get negative 3x plus 4 equals 2x squared minus 3x plus 4. I'm going to have an x squared, it looks like. So now we got to think, when we have an x squared, typically how do we solve x squared problems? Quadratic formula. So we get it equal to 0. We don't try to get x equals a number, because we're going to have this x squared. It looks like we might have an x. So let's try to get everything else over there. So let's add 3x and subtract 4. We want to get the thing equal to 0. So we could save ourselves a little work by basically doing two steps at the same time. Wait a minute. Shoot, no matter how. So I see I've got this negative, but when I rewrote it, I put a plus 4. It's I think I just need some deep sleep. I need a weekend of deep sleep. Okay, so then we get 0 equals 2x squared. These guys cancel. We get a minus 8. That was a minus. You could factor out a 2. So this becomes 2x squared minus 4. Divide by 2. 0 divided by 2 is still 0. So we could solve this x squared minus 4. We could use the quadratic formula, but we could also use factoring. You could also add 4 to both sides and then take the square root, and you get plus or minus 2. Or you can notice that x squared minus 4 factors into x plus 2, x minus 2. But again, sometimes we forget. At this point, if you wanted to graph it and if you recognize that it's where it crosses the x-axis, right? It would cross the x-axis at positive 2 and negative 2. But at least get this much work, that you've set them equal. You've got this. We get x equals negative 2 and x equals positive 2. Next step is to sketch the graph. We've got a little thing here. Remember, we had one intersection at 2, negative 6. So we would look at from the graph. And again, you could sketch this graph from looking at the graph. You don't have to try to make it all up. And there was another at negative 2, 6. So we're really just recreating these. We could go back and take a look. And so one went up like this. It went through there and then came back down. The other one, how did it go? It went down like this. That's where they intersected, came down, and it doesn't have to be beautiful. It just has to be sort of on track. That's what we saw. And what are we looking for? And again, you don't have to use different colors, but we're looking for the area between those two curves. So that's what we're looking for when we ask you to sketch the graph. Okay. Just take your graphing calculator, graph it, and then do a little bit of artwork. If I can do it, you can do it. I'm sure Most of you will do a much better job than me. Some of you will do as bad of a job as I did, but, and again, watch the other video, I did even a worse job that time, so I've had some practice. But again, put the intersection points, do it. That's all we're going to use it for. So we're okay, but be able to do that. And then just a little bit of advice when you're working through the test, try to, I particularly like to just ask a question and let you fill it in. These coordinators like to ask step-by-step questions, so try to, when they're asking a part, to put the work for that part and the answer for that part underneath that question. It makes it easier to score. I know sometimes some of you do what I would do, is you just work it through and then it's all there off to the side, but you may not have answered all the part step-by-step questions. Okay, so this is kind of that. Write the integral expression. Now it's not solve it, it's just to write it. We're supposed to evaluate it down into D. So what's the integral expression? That's the integral. We're going from -2 to +2. Now is where we write the functions. Negative x squared minus 3x plus 4 minus 4 plus 4. Okay. And then we're going to subtract. I could put a parenthesis around that to indicate f of x, but x squared minus 3x minus 4. And if you want to just leave it at that, that's fine. But just write out what are we integrating. If you want to simplify it in this step, that would be fine too. I'm going to simplify it in the next step because that's where they want me to evaluate it. So I'll do it down here, but again, you could do it up there. Wherever you want to put this step is okay. So that's what I mean. And I do try to take a look over everything and make sure if you've got the right work that it's there. So then it's negative x squared. Remember, this gets distributed. So we've actually already done this, but let's do it again. So this distributes. So I'm going to get negative x squared minus x squared. That's going to be minus 2x squared. I'm going to get negative 3 plus 3x, or say negative 3x plus 3x. That's 0. So those guys cancel. And then I'm going to get 4 plus 4. So that becomes plus 8 dx. And again, we just go through the same steps we did earlier using FTC, which is the fundamental theorem of calculus. We integrate it, add 1 to the exponent. And again, maybe here I'll switch the order. Let me do the 8 first. So I get 8x minus 2x to the third, right? Add 1 to the exponent, divide by that new exponent. And we're just going to go from -2 to 2. Now last time we went from -1 to 1 because that's what they told us to do. That's what the book did. But this time we're going from the intersection points, which we had to find. Okay, so we're going to get a different answer, but we'll be able to also check it with what we've got going. So again, fundamental theorem of calculus, put in the 2 first. So we get 8 times 2 minus 2, 2 to the third power over 3. So notice how this one's going to be a little bit more of a calculation thing. And then we're going to subtract 8 times -2 minus 2 -2 to the third over 3. And I'm not sure I did all of this in the other class, so let's go ahead. 8 times 2 is 16. 2 to the third is 2 times 2 times 2 is 8. 8 times 2 is 16. So this becomes minus 16 thirds. And then we get this minus. Over here, we get 8 times -2, which gives us a negative 16. And we get -2 to the third, which is -8. -8 times 2 is -16. But then we've got this negative. Negative and negative is going to make that a plus 16 thirds. Let's change our colors. So what is 16 minus 16 thirds? Again, if this is WebAssign, we need to have it as a fraction. If it's on the test, you could just plug in your calculator, give me the decimal, that would be fine. But we'll do it how WebAssign might want us. So common denominator of 3, what is 16 times 3? That's 30, 48, right? 3 times 6 is 18. So that should be 48 thirds minus 16 thirds. And I'll do that part together. So 48 minus 16 is 32. Is that right? 32 thirds. Over here, we're going to get negative 48 thirds plus 16 thirds. And again, same thing, except we end up with negative 32 thirds. But we're subtracting that. Negative and negative make a positive. So we really just add 32 plus 32 is 64 thirds would be the answer that we would put into WebAssign had this question been in WebAssign. Let's turn it to a decimal so that we can check it with the technology as well. What time is it? 64 divided by 3, 21.333. I think that's what we ended up with. So again, the nice part about this is we can always check with the technology. We can get the area between these curves, not directly, but we go back to our y equals, and in this case, y1 minus y2, y1's on top. We're going to turn this one on. We're going to turn these guys off. And you're going to see, because we did the intersection points, that this parabola that we end up with crosses the x-axis at negative 2 and 2. So we go to the graph, negative 2 and 2. The area under this curve is the same area as between those two curves because we're just subtracting the two. So now we can use the technology, second calc, number 7. But this time our boundaries go from negative 2, enter, and the upper limit is positive 2. It graphed it in there, 21.333. I'm feeling so much better today because my numbers are matching up. But again, if it doesn't match up, it's, oh, I made a mistake. Let me go back, and it's probably a negative. It's I had it. So that's why we want to do this. Okay, we could get by without it. We could just leave it there. But don't we feel much better when we got one answer and we match that answer with another method? We go, yeah, I got it. Okay, of course. And actually, I got one right, even though I did make a mistake. But I made 2 mistakes. And that's what I love about math. Math is one of the few topics that 2 wrongs do make a right. If you make 2 mistakes, oftentimes they counterbalance each other. I got through a lot of classes that way. Oh, I made a mistake, but I made 2 mistakes, and so I actually got the right answer. It's cool. Okay? Yes.
So when you're sketching the graph, over what interval should I be?
Just make sure you get the intersection points. So yeah, that's a good question. Yeah, the main thing they're going to look, and they kind of help you on the test because they give you, they'll give you a graph of the right size, so you don't, you won't have, you'll put whatever's on the graph. We don't really care about all of this. I mean, come a little bit to show there's an intersection, but even if you only drew this little part here, that's fine. It's, I'm not, as long as draw something that's reasonable. So basically just get those 2 intersection points, boom, boom, and then kind of connect them. And I'm not gonna get anybody on their artistic abilities because mine are challenged as they are. So got something, yeah. And it's a few points, but do draw that graph. because that's basically what we need to do. And if you follow through like this, you'll be just fine. Okay. So here's the official sort of from the textbook, what are we doing? So first thing is we're given two functions because we want the area between those two functions. We need to graph it first so that we can find those points of intersection, or we can do it algebraically. And again, if when the test says do it algebraically, we have to do it algebraically. We may do it with the graphing calculator as a help, but be able to put enough steps that, yeah, you set them equal and then solve for x. And then we can, but from the graph, we see which one's on top, which one's on the bottom. And we're going to do one where one starts out on top, but they cross over again, and then it switches. So we're actually going to have to do two integrations. We'll do that on the next one. But we know that from the graph. So it's important, graph the two functions, and that will tell us pretty much everything we need to know. It'll tell us where the intersections are and so forth. And then determine the area of each region. Again, this time we only really needed to find one region. We're going to do the next problem. There's actually end up being two regions. So we find this area, and then we add them together. Just kind of makes sense. So let's do one. This one comes from the homework, or at least it came from the homework from spring semester. That's where I had it left over. I think I've got one after this. We could do that one too, but because I didn't do it yesterday. We're 8:30. We've only got 15. We may just stop with this one, and maybe I'll do this one as the other one as a review. But okay. So it says find the area of the indicated regions. We suggest you graph the curves. I suggest you graph all of the curves. Okay. And then we can use our technology. So basically, they give us two curves, two functions, y equals x and y equals x to the third. And they give us the boundaries going from -1 to 1. So the first step, let's graph it. Come back here. Let's clear this out. Let's clear that out. Let's put in y equals x and y equals x raised to the third power. I'm going to turn off this y1, y2 because what I need to do is find which one's on top. I'm going to graph it. And it's kind of hard to see, but since we're only going from -1 to 1, what I can do is maybe zoom in on this area. And I'm going to show you when there's something called a zoom box. I'm going to use a zoom box. It gives me this little corner, and I just move the corner. Maybe I'll go to not that far. Come up, not that high. Maybe I'll draw a little box. I'll put that as a corner, and then what it'll do is it'll zoom in on this box, and we'll get a better view. So you can see the red curve, which is x cubed, is on top first from -1 to 0, and then from 0 to 1, the function x is on top. So they switch. They switch on us. We're going to have to do two integrations. We'll find the area of the left-hand side of the y-axis and then the right-hand side. But this tells us we can see the intersection at -1 and the intersection at 1, and that's what they told us to do. We can also see, hopefully, and if you didn't, you could find it out, but there's going to be an intersection here at 0, 0, 0. So what we're going to do is we're going to set up two integrations, one going from -1 to 0, the other going from 0 to +1. And I'm going to switch the ones as we go. So let's come back to get this one set up. And I think there's one or two in the homework that you'll have to do something like this. So yeah, we'll leave it as blue. So with the first one, this was on top. I'll call this y2. We'll call this one y1. So it was x to the third minus x and that happened from -1 to 0. So we're going to do that integration. We're going to add to it the other side, which was going from 0 to 1, and that one was x minus x to the third dx. Okay, so because they switched which one was on top. So we always got to take the one on top minus the one on bottom, the one with the bigger y values minus the one with the smaller y values, so that we get a positive, because again, we're looking for area, it should be a positive number. How about on that step, we okay? Okay, so again, we get it from looking at the graphs. And most of these, I think all of them, they'll give you nice endpoints to find and intersections. So again, then the step is just integrate these. So x to the third becomes x to the fourth over 4. X to the first power becomes x squared over 2. And again, this one we're going to go from -1 to 0. So we do that instead of the plus c. So that gives us an answer. And then we're going to add this one. So x to the first power becomes x squared over 2. Right? Adding 1 to the exponent, dividing by the new exponent. Minus x to the fourth over 4. This one we're going to go from 0 to 1. Okay, and again, we go through this, and each one we just evaluate it by plugging in the top value first minus the bottom value. So we've got double problems here. So we will plug in 0 to the fourth over 4 minus 0 squared over 2, and you'll see, yeah, that's all 0, so we really didn't have to do all of that. But then we subtract off -1 to the fourth power over 4 minus -1 squared over 2. Okay, so that's this first part. The second part over here, we're going to plug in 1. So that's 1 squared over 2 minus 1 to the fourth over 4, and we're just maybe thankful that it's 1, because 1 to any power is still 1. Subtract off plugging in 0, and again you'll see we end up with 0. Zero squared is 0, divided by 2 is still 0, 0 to the fourth is 0, so this whole part here is just a big old 0. So this is 0, this is 0, that makes that part nice. Now we just need to kind of do the arithmetic part here. 1 to the fourth is, and it's going to be a positive 1, right? Because there's this negative outside. So we get 1/4 minus 1/2. You get a common denominator. 1/2 is 2/4, right? So we could rewrite this as 2/4. 1 minus 2/4 gives us -1/4 with a negative here, so we're going to get a negative. That's going to give us a, let me do it up here, positive 1/4 from that first part. That's here. Over here, let's come back to this color. We're going to go plus. We get 1/2 minus 1/4, so that's 2/4 minus 1/4. That gives us a plus 1/4, and we'll leave that as plus 1/4. So we got 1/4 for that part, 1/4 for this part. You add them together, you get 2/4, which equals 1/2, which is also equal to 0.5 as a decimal. So if you check it with your calculator, you can do that. Notice though, to check it with your calculator, you have to do two separate checks. You have to check from -1 to 0, and then you have to check from 0 to 1 where you switch it. So this is one, I mean, it can be done. It's a little complicated. Maybe if we finish off with this one, let me just show you how you would do that. So this first one, y2 is on top, y1 is on the bottom. So I would come here. Let's turn these guys off. And y2 is on the top. So that's why I've got this one saved down here. Now I've got this one, y2 minus y1. So this is x to the third minus x to the 1. And that's going from -1 to 0, right? So it's just kind of following what we did. We look at the graph. That's what we get. And we know we got it right because it's above the x-axis. We do second calc, number 7. And we want our boundary to go from -1 to 0. That's it. 0.25, 1/4. That's what we got. So that's half of our area. To get the other half, we switch the integration. We switch which one's first, which one's second. So we come back to y equals. We're going to turn this one off. And we're going to turn this one on. And notice the graph will actually look different. So now this part is the part we want, and that one has a boundary when we integrate from 0 to +1. So our lower boundary is 0, our upper boundary is 1, and we've got 0.25 or 1/4 again. 0.25 plus 0.25 is 0.5, 1/2. We can check it this way. But again, we had to do 2 different integrations, because of one was on the top, one was on the bottom. Now, you could have just said, well, we could have done it with the 1 and the one that was under the x curve. We would have got a negative, and then we just say, okay, mentally that's going to be positive. So you can do it if you see that shortcut. But it's good to go through this that you've got to do it as 2 different integrations. So it all starts with looking at the graph. Okay, so you're going to need some graphing finesse here, some graphing skills, be able to find intersection of 2 functions. But then if you can do that, you can also use the technology to get the integration, because we're getting the area between the curves, right? And use this fundamental theorem of calculus. But this is what I mean. Test 3 is just this stuff. So notice this is really the same thing we were doing on Tuesday, just a little extra added, right? Because we got that extra curve. It's not just under the x curve, x-axis. So these 2 go very well together. What we did in 13.1 was to get the antiderivative. We're doing that today as well. So we're getting practice all the way through. So these assignments are like one big topic that we spent 2.5 weeks or so doing, and we will get Tuesday as a review day. So over the weekend I'll review the review and maybe put some new stuff in, maybe some video. I'll let you know through announcements, and then Tuesday we'll put it all together, get some good practice, and hopefully score really strong next Thursday. Questions, concerns? Ready to move on? Awesome. Okay.